Hi, everyone. My name is Rohan, and I'm really excited to be presenting today. My talk is titled Can Teens Learn Clojure? It's a bit of an unconventional talk, but I still hope you can take something away from it. So before I dive in, I'm just going to give a brief overview of how the talk will be structured. First, I'm going to talk a little bit about myself, how I got involved with Clojure and functional programming, a really cool effort I was part of this past summer to try and spread these concepts to more young people, especially high schoolers and first-year college students, and some ideas I have for how I can continue this effort, as well as for things the community can do to sort of encourage more young people to explore functional programming and Clojure. So again, I'm Rohan. I'm a current high school senior based in New Jersey, and I work part-time for the Wolfram Institute. I'm really interested in applied mathematics, but I also like to dabble in synthetic biology, machine learning, and programming language design on the side. If I'm not doing one of those things, you'll probably find me blogging, though I haven't tended to my blog in quite some time, or reading sci-fi or dystopian fiction, or playing tennis. So just to get right into things, I've been coding for a while. I started programming around fifth grade, which I think is roughly 2015. And I started off with Python. And then, from there, I sort of explore the languages you're told to explore after Python, like JavaScript, C++, and Java. But I didn't really find the same sort of joy in learning these languages as I did with Python. And I think that's for two reasons. First, I hadn't really discovered what I was passionate about creating with code yet, but also learning these languages wasn't as much fun as learning Python had been. So with Python, I was just thrust into this whole new world where these new concepts were attacking me from every direction, and I had to learn all this new stuff from the ground up. There were all these new ideas and concepts sort of constantly bombarding me, and I found that really exciting. But in learning these other languages, I realized that their core ideas don't change very much from Python. So, they might have different paradigms. Sometimes some of them might be object-oriented, whereas Python's not strictly object-oriented. They might have better performance in different scenarios, but syntactically and semantically, they're not that different. And the sort of core underpinning ideas of the language aren't that different either. So learning these languages wasn't as much fun for me as learning Python was. That's the gist of it. And then lo and behold, I discovered Clojure. So technically, I discovered Clojure the summer before my first year of high school, but I didn't dive too deeply into it. Then that same year, the pandemic struck in the spring of 2020, and I heard about Clojure again, thanks to the advent of a company called Roam Research, which makes this super powered note-taking app, basically, although that's a bit of a sort of underestimation of what they do. And so I was interested to have heard of Clojure twice now, and I decided maybe I should check this out. So as I did some research, I found out that Clojure was associated with a lot of words and concepts I didn't know. Clojure was a Lisp, it was a functional language, it was homoiconic. And so what I saw were all of these new ideas and concepts that I could learn. And this was really exciting for me. It was like learning Python all over again, being faced with this completely new language that I just knew nothing about and had a lot to teach me. And so I began to really dive into Clojure over that time during the pandemic. So as I'm sure most of you know, learning Clojure isn't easy. Being a high schooler and without that much programming experience, it was probably doubly hard for me, especially because I had some unearned arrogance from those other easier languages. And so I started off with Clojure programming, which seemed to me like a very de facto textbook style thing. And so I just saw it as a very first resource and I started reading it. It was very pedantic and very textbook-like, which I should have, I guess, surmised, given that it was a textbook, but it was really difficult for me to digest. And so I began to feel like Clojure was maybe not for me. The same thing is true for Emacs. Now, don't worry, I eventually converted to Emacs later on, but in the beginning, sort of playing around with all those key bindings and understanding how to actually run code from Emacs and get results and link everything to a REPL, all of this was really hard, and it was a very high barrier to entry for me, not having played with any of this before. Luckily, though, I was able to find some resources that encouraged me and pushed me to continue learning Clojure. The first of those is Clojure for the Brave and True, which is also a textbook sort of style introduction to Clojure, but it's much less pedantic. It's very colorful, very visual. It uses a lot of analogies, and it's really good for someone coming from a non-functional language. And so I really took to this book, and it sort of got me addicted to learning Clojure because I was finally understanding the concepts in a very intuitive way. And so I was testing all of these concepts out by using Replit instead of Emacs. And Replit is a service which lets you run code in the cloud. So I could just start up a Clojure REPL, type on my computer, and instantly get results back. All of this running in the cloud without any setup required for me. And together, these two tools really streamlined my Clojure learning process and made it really easy to play with the ideas rather than get everything set up and worry about all these technical issues and comb through long websites about various cryptic errors I might be getting. And so I really started to take off with Clojure. Some other cool resources I used were Exorcism, which is a site where you can upload code in Clojure or a variety of languages to sort of solve various programming language problems. And then you get advice from mentors to refine your code. So I began to learn more about functional programming and functional programming idioms, revising a solution to the same problem 1 or 2 times, sometimes even 3 or 4 times, to sort of understand that there is a optimal way I can do this in Clojure that is different from Python or C++ or Java. Just quickly, 2 other really cool resources for me were the YouTube channel Code Report and Practically. So Practically has a bunch of articles on building websites and apps with Clojure. Code Report was really cool for me because it talked about Clojure, but also functional programming more broadly and compared a bunch of different programming languages. So I began to get the sense that Clojure was not alone. There was this whole universe of sort of alternative programming languages out there. And so I started to get really interested in this whole idea. So that summer, after the quarantine of the springtime, I sort of put all these efforts together and created my first big Clojure project, which is my personal website. And so by this time, I was starting to feel really confident and competent in Clojure. And I wanted to sort of take a next step into that world of alternative programming languages that I had sort of got hints of before. So over the rest of my high school career, I really just dove into functional programming. 2019 and 2020, I really focused on Clojure, but then I began to explore languages like Haskell and the Wolfram language, as well as OCaml and even APL, which is technically not even a functional programming language, but an array-based programming language. And all of these languages really began to change not only how I coded, but how I attacked and viewed problems, because functional programming seemed to me a lot more elegant and a lot more mathematical than procedural or object-oriented programming. And I was really taken in by these ideas. So functional programming became a sort of hobby or obsession of mine, which is perhaps not the most common thing for a high schooler, but I was just really in love with all of these super cool programming languages. I even tried building a programming language of my own, a simple Lisp. So I know this is going in a bunch of directions now, but I promise it will all tie back together in the end if you just bear with me. So I had this idea for a Lisp that could do automatic differentiation and be used for machine learning. So I spent a good amount of time sort of writing the whole thing out in C, and this gave me an even deeper understanding of Lisps and Clojure. And so at this point, I was really beginning to wonder, why does no one know about this? Now, obviously, people knew about it, but in my high school computer science classes, even on the sort of mainstream computer science web, talking to my peers, both in my school, even though there's not a bunch of computer science people in my school, but also friends I've made through other communities or hackathons or things like that, really none of them seem to know about functional programming. And that was super puzzling to me because it's this really powerful tool that it seems like is being underutilized. So I got this idea that maybe I could be part of an effort to sort of spread functional programming to the masses in terms of teens and high schoolers and sort of juvenile coders, if you will. And so I had this idea to sort of tap into a community I was already a part of called the World Science Scholars, which is this group of 40 high schoolers from around the world each year who have shown some sort of penchant for math or science. And so I reached out to a bunch of people, and I eventually assembled a team of around 6 or 7 people that were really interested in this idea as well, even though some of them hadn't heard of it before. And so we agreed that we would spend the summer, and this was just this past summer, helping other teens around the world learn functional programming and learn it better ourselves as well. And so the sort of what emerged out of that was the Paradigm Conference. And so we announced it in early May. It ran just over 2 months ago, a 3-day conference from September 23rd to the 25th. But a big part of this was the intervening summertime, where we released a bunch of resources to help people learn functional programming. So we released a lot of educational YouTube videos. We assembled these long lists of resources so that people could take a more straightforward journey learning Clojure. And this was where my own sort of circuitous learning journey benefited me because I was able to guide people down an easier path. We even started a Discord community to sort of act as the place where teens can go and ask about functional programming. And so all of this was really cool, and we started to get a lot of traction. So when the conference eventually rolled around, and I'll give some more stats on the conference and turnout later, it had two components. So a programming competition component and a hackathon component. I sort of overestimated what people would be able to do. And so most of what happened was just in terms of the coding competition. And so there were 5 problems, mostly adapted from Exercism. And we used this interface called DOM Judge for people to submit their problems in Clojure and a variety of other languages. So there were 5 languages in the conference: Haskell, Clojure, OCaml, Wolfram Language, and APL. And this is just sort of what that interface looked like. So I'm quickly going to step through those problems, or at least 4 of them, to sort of give you a sense of what our participants were actually faced with and what they were learning, and sort of the level to which they can use Clojure. They obviously can't use all of its advanced features, but they started to get a pretty good understanding for how you solve problems in Clojure, and so by extension, how you solve problems functionally. So this is an example of one of the problems we had. This is the first problem. I gave participants basically this. Our team assembled a bunch of boilerplate code for each problem. So here's a function that we want them to fill out. Here's some code to read from the input file and print to the output file. And so this code is asking you to calculate the Hamming distance of 2 strings, or basically how many characters differ between those 2 strings. And so I'll quickly just say this as well. One of the really cool things about the conference is that it's not a programming competition in the traditional sense of the word, because the second day we actually went over all of these solutions together as a group through a fun sort of Kahoot. And so it was really about learning just as much as it was about the prizes. So having these really sort of functionally idiomatic solutions, even if they're not the best solutions, because I did write them, so there is probably in each case a somewhat better solution, but solutions that in general reflect functional programming principles and idioms, this was really important so that people could take away what the best sort of approach to these problems were. So for this problem, this was sort of the solution our team came up with. And it's not as elegant as I would have liked, but it's still pretty elegant. So we use a let statement here to sort of define all these helper variables. So we get the each of the strings in character form, and then we count up all the differences between them. And we also check to make sure they're the same length. Otherwise, a Hamming distance will have no actual meaning. And so if they are, then we sort of sum together all those differences. And if there wasn't a difference, we would just have a 0. If there was, we would have a 1. And so that's how we calculate the Hamming distance. So it's a pretty easy problem. Problem 2 was also pretty easy. Again, you can see this is what the boilerplate code looked like. This, I think, is a much more elegant solution because we can just do everything using a thread last macro, and so show a very sort of linear transformation of the functions we're using and how that sort of comes together to build the program you want. So here we're taking a string. Oh, and I should mention, an isogram is just a string that doesn't have any repeat characters, excluding spaces and dashes. So once again, we split the string into its component letters. We sort of disregard all those dashes and spaces. Then we get the frequency. So we create a hash map of how many times each character repeats. We extract the values of that hash map. And that's just in this case, how many times it repeated, and make sure everything is less than or equal to 1. So in this case, it would actually have been better to just make sure everything is equal to 1, because you can't have sort of negative instances of something. But this was the general template of the solution. Problem 3 was quite a bit more difficult. So here we just told the participants implement a veneer cipher. And so that's a cipher that's slightly more complicated than a Caesar cipher. You basically have a key, which you replicate across the phrase that you want to encode, and you just add together the alphanumeric representations of everything. So this is sort of the main function that we came up with as part of our solution. And because it's a bit more complicated, I'll just highlight the individual parts that are important. So first, we take the phrase and our key, we pass them through a function which will convert everything to its alphanumeric representation. So A becomes 1, B becomes 2, etc. And before this, we also use the cycle function with this helper format key function to repeat the key as many times as there are letters in the phrase. So the next thing we do is we add these 2 things together. They're all in their number representations right now. And then we basically mod 26 everything to convert it back to some number under 26, and then we can convert that back into a letter. So just one more problem to give you a sense of the difficulty, how it increased. This problem asked people to create a pig Latin translator. So the way we solved it was with regular expressions, and nobody actually ended up solving it this way. So this was a really instructive sort of lesson. And so again, here's the sort of main function here where we just match against these regular expressions. And if we find a match, then we apply the transformation logic to create something in Pig Latin. And again, we can express this really nicely with functions that basically just use threading macros to show really clearly what is happening. So that was just a quick taste of some of the things we learned over the conference. There was also a bunch more complicated stuff and more advanced topics that we sort of taught in that intervening summer period. But you're probably wondering, well, how successful was this? So just some quick stats. We ended up reaching over 300 teams in terms of our YouTube videos, our resource lists, our Discord, and people actually signing up. It was really a worldwide thing, which was super cool for me because coming from the US, I was sort of expecting attendance to be mainly within the US, but people really joined us from all across the world. So we had people join us from Ukraine, from Brazil, from India, really from all over the world. Only around 50 people attended the 3-day conference every day. And a lot of that was because of differing time zones, which is something I probably should have taken into account and something we will take into account for future years. But something that was also super cool is we got a lot of support from the community, from functional programming companies, and we're able to raise over $10,000 in terms of swag and prizes. So just to clear up these graphs over here, this is just showing all the different countries that we got signups from. Over here is the relative age range of our participants. So most people were seniors in high school or just starting college, although we did have some notably younger categories. And it was really cool to see people who were only like 14 or 15 years old get on and write Clojure code and write Haskell code, because that was sort of the age that I was when I got into this. So it was really cool to see that cycle sort of continue. And then here's just a quick graph of the relative interest in all of the different languages in our event. And people were allowed to choose multiple languages, so it's not that telling, but just to give you some sense of interest. I think what was even more important, though, is the sort of experience that attendees had. And I think this is what really validated the conference, because on my part and on the part of our team, it was really an experiment. Like, for all I knew, I was just some weird teen who was really taken in with functional programming. And that was not a thing that most people who were my age, who were interested in computer science, would be taken in with as well. But the feedback we received points otherwise, basically. So I think some of the most important feedback were things like this comment here, which talks about the conference helping them understand a language and use a language better than they could after just watching some passive tutorials online. There were even people who had really studied over the summer and were expecting something more difficult. So to me, as an organizer, that just shows how successful they were in learning a functional programming language, which is really cool. Some people suggested possible languages for the future, like Prolog, and logic-based programming was a paradigm that we did not represent this year and something we are interested in representing in the future. We also had a bunch of talks from functional programming companies to sort of show people, especially people who are at a pivotal point in their career, deciding what to study in college or what to apply, what category, what major to apply for as a high schooler going into college. They were able to see that companies really do use functional programming in industry, and they use it to do some really cool things. I think actually the coolest thing for me, though, was getting these emails from people months after the actual event saying that they continue to use the language they learned and that they're continuing to explore functional programming concepts. And that was sort of the validation we were hoping for with this experiment. Teens really do enjoy functional programming when it is taught to them in a way that they can understand and when it is made very easy and accessible to them. So answering my initial question, can teens learn Clojure? The answer is really they can. And this flagship event made clear that not only can they learn it, but they should learn it because there are a lot of benefits to that. So we're thinking about what other things can we do building off the momentum of the Paradigm Conference to move towards this goal. And so some ideas we have include creating a more open source Clojure curriculum, making a more extensive resource list like the one we did. There are a lot of high school events trying to get people to code. Why don't we have events that try to get people to code in functional languages? Things like Advent of Code and Hour of Code, we can make those Clojure themed, for instance. But more generally, I think it's important to get Clojure in the classroom. And so as a high schooler currently taking AP Computer Science A, which is one of the de facto computer science courses in high schools across the US, I have an interesting perspective on this. I'm in the classroom, but I've also studied functional programming outside of the classroom. And so this APCSA course uses Java as its main language. And I think that makes it really ripe for disruption by Clojure, because Clojure and Java, well, Clojure is implemented on top of Java, so they share a lot of similarities. Clojure can interoperate with Java, so that's a benefit. But also beyond that, Clojure is one of the easier functional programming languages to learn, I think. You don't have to think about types unless you really want to. Also, Clojure and Lisps in general have been a really big part of computer science history. And I think that's an important thing we should learn in our classrooms as well. And so one of the things I've been thinking about is how can we create a course that is basically like APCSA, but for Clojure and functional programming. And that's something I'm really excited about right now. So here is a sample sort of curriculum for the APCSA course. This is the curriculum I'm going through in my classes right now. And I think it's actually pretty easy to sort of map this onto a Clojure curriculum. So the first unit or chapter is all about primitive types, which we can keep. The second unit is about using objects. For a Clojure course, that would become about using functions and using the REPL, because REPL-driven development is obviously a really big part of Clojure, one of its main advantages, and functions are obviously the bread and butter of any functional programming language. So the next unit is about Boolean expressions and if statements. We can just map that to using special forms and control macros like for. This is actually a more expressive version of what they have in the original course, but I don't think it's that much more difficult to learn. Iteration is just map and reduce. Again, bread and butter functional programming concepts. Instead of focusing on writing classes, we would focus on writing and composing functions. And then there's a bunch of chapters on arrays. We can sort of map all of those to functions that create and manipulate sequences and collections and sort of understanding the different performance benefits of that. All of that stuff in the middle, I think, just maps easily to recursion and Java interop. And recursion is listed at the end here because it's very difficult in Java, but it would be a lot easier to go over in Clojure. I think in general, a lot of these concepts are partitioned, not because they're difficult in and of themselves, but as someone who's taken tests and assessments in this course, they can actually be quite difficult, the tests on these concepts, because everything is stateful. Managing state is like one of the main things you have to learn when going through this course. And in Clojure, because most things are immutable, we don't even have to deal with that anymore. So we can learn more in different units. We can package more things together at once, and we can still expect students to sort of go through that stuff, because Clojure is a language which you can reason in really easily as compared to Java, which you cannot, especially the sorts of questions they put on AP tests. And I think the final sort of crowning achievement of this would be to write a Lisp in Clojure. So I mentioned I wrote a Lisp in C. I did this using a really cool Make a Lisp project. It's an open source project on GitHub. And you could do the same thing in Clojure in about 1 or 2 months. And I think that's really cool, because if you know how to create the language you're using, that gives you a very sort of self-contained box of knowledge. You really understand what is happening on a very low level. And so you can really say that you're walking away with a deep understanding of functional programming. And so here, the main sort of concepts you'd be learning in this course are composability and functions, as opposed to modularity and variables. And so I think this is sort of a blueprint for how we could go about creating an AP functional programming course. So I'm really excited about that. But there are a bunch of other things that we can do to move in this direction. We're currently looking at what things we can do to create the next iteration of Paradigm Conference next year. So we're interested in doing things like partnering with various organizations that help kids learn to code, and sort of look at the flip side of that. How do we help kids learn to code in functional programming languages? We're interested in partnering with schools too, from local computer science teachers in my school and the schools of our other team members, as well as people at the university level who teach functional programming and might have some insights on how we can refine our teaching process. We also think it's important that there are like smaller events throughout the year that sort of fill the time between this big conference. So things like I mentioned, Advent of Code, which is a main way that high schoolers learn to code, and it happens every December. And also just having sort of periodical speakers, social media posts, challenges, and stuff like that. In general, we're really excited about advancing this mission forward. And so if you have any ideas or contacts or things you'd like to talk to us about, we'd definitely love to talk to you about it as well, especially the sort of AP functional programming course idea. I've sort of built up the Paradigm Conference by just cold emailing a bunch of people, but I don't think cold emailing will really work if I want to infiltrate the College Board. So we'd really love to collaborate with others who have more experience here to streamline this process. But yeah, that's really all I wanted to talk about today. So thank you for listening to me, and feel free to reach out if, like I mentioned, you're excited about any of these ideas. I know this was a bit of an unconventional talk, but I hope it was exciting for you, because it was definitely exciting for me to present. Thank you.